Hi everyone, welcome back to my channel. This is Varun. Today I am going to explain you about Analyze Hamming codes, including their construction, error detection, correction and its applications. Firstly, introduction to Hamming codes. Introduction codes Hamming codes are a family of linear error correcting codes. They were developed by Richard Hamming in the 1950s to improve data transmission reliability. These codes are widely used in computer memory and communication systems for error detection and correction. Here is a shortened Hamming code, matrix type 1. Here you can see the Hamming codes how they are displayed. Importance of error detection. Errors can occur in data transmission due to noise or interference. Error detection is crucial for maintaining data integrity and reliability. Hamming codes provide a systematic way to identify and correct single bit errors. Transmission errors are caused by thermal noise, impulse noise, signal distortion during transmission, crosstalk, voice amplitude signal compression, quantization noise, jitter, receiver and transmitter out of sync. Basics of Hamming codes. Hamming codes can detect and correct single bit errors and detect double bit errors. They are constructed using parity bits that are strategically placed in the code word. The Hamming distance of these codes is essential for their error detection capabilities. A received code word is in a binary operation plus error code word is also in binary operation, which gives us transmitted code word. Here is a D9, P8, D7, D6, D5, B4, D3, P2, P1 are the inputs given to this Hamming codes. Construction of Hamming codes. The number of parity bits is determined by the equation 2 is to the r g q m plus r plus 1. Here m slash is the number of data bits to be encoded. The total number of bits in the code word is n is equals to m plus r slash. Here is a binary numbers. P1 is equals to 1, P2 is equals to 1 and P4 is equals to 1 and P8 is equals to 0. Positioning parity bits. Parity bits are placed at positions that are powers of 2, 1, 2, 4, 8, etc. Two-dimensional parity check. Each parity bit checks a specific subset of bits in the code word. This arrangement allows for synthetic error detection and correction. Here is a brief explanation about the two-dimensional parity check in the binary operations, which is data to be sent here, a column partitions and a row partitions. Example of Hamming code construction. Consider a 7-bit Hamming code where m is equals to 4 and r is equals to 3. The code word structure will be represented as P1, P2, D1, P3, D2, D3 and D4. Here P represents parity bits and D represents data bits. Here is an example of it, where the example is shown in the form of a diagram. Calculating parity bits. Parity bits are calculated based on the even or odd parity of the bits they cover. For each parity bit, the corresponding bits are summed and the parity bit is set to ensure the total is even. This method ensures that any single bit error can be detected. Here is the original data, even parity, parity and odd parity. Error detection mechanism. When a received code work is checked, the parity bits are recalculated. If the recalculated parity does not match the received parity, an error is detected. The position of the error can be identified by the combination of parity checks. Input as like Fox checksum function. Here is a checksum function which displays on the screen. The red fox jumps outer the blue dog. Checksum function is in the operation. Error correction process. Once an error is detected, the position of the erroneous bit is determined using the parity checks. The specific bit is then flipped to correct the error. This correction process is efficient and can be performed in real time. Example of simple even parity check, where the sender and the receiver are the two components displayed, where the sender sends the input of the error correction process, and the receiver receives the accept data or reject the data. There are two types in even. Limitations of Hamming codes. Hamming codes can only correct single bit errors and detect double bit errors. They are not suitable for applications with high error rates. Means Hamming codes have the limitation of doing it like one or two single bit or a double bit errors, but they are not. If many error bits are there, they can't even code it. So there are only single and detect the double bit errors. They can't detect more multiple error detects. More complex error detection correction codes are required for large data sets and higher reliability. Hamming code. Applications of Hamming codes. Hamming codes are commonly used in computer memory systems to ensure data integrity. They are utilized in telecommunications for reliable data transmission. These codes are also applied in satellite communication where error rates must be minimized. Here is a Hamming code and the example where data 1001101 and the code 10011000101. Here is a Hamming code example by where the binary numbers are shown in the given example. Hamming codes in data transmissions. In data transmission, Hamming codes enhance the reliability of the information sent over noisy channels. They help in reducing the need for retransmissions, saving time and bandwidth. Hamming codes are an integral part of protocols in modern communication systems. Here is the same example of the data and the code of the data transmission, which is in the right side of the slide. In data transmission, Hamming codes enhance the reliability of the information sent over noisy channels. Where the more noisy channels, there will be a data transmission in it. Comparison with other error correcting codes. Hamming codes are simpler compared to more advanced codes like Reed-Solomon codes. While they are effective for single bit error correction, they are limited in correcting multiple bit errors. Understanding the differences helps in selecting the right code for specific application. Hamming code variants. The variants means the different type of Hamming code variants. There are various types of Hamming codes including Hamming 7,4 and Hamming 15,11. Each variant differs in the nuclear number of data and parity bits used. Selecting the appropriate variant depends on the application requirements. Hamming code decoding process. The decoding process involves checking the received code word against the expected parity. If an error is detected, the location is identified and the bit is flipped. The resulting corrected code word can then be interpreted as the original data. Hamming code in digital communication plays a vital role in digital communication systems, ensuring accurate data transmission. They are fundamental in protocols like Ethernet and Wi-Fi for maintaining data integrity. The implementation of Hamming codes has significantly improved data reliability over the years. Future of Hamming codes. As technology advances, the need for robust error correcting codes continues to grow. Hamming codes may evolve or be integrated with some complex coding systems. Research into error correction remains an active field aiming to address modern challenges. There is an example of Hamming code of 7,4 with block encoders. Summary of key points. Hamming codes provide a reliable method for error detection and correction. Their construction relies on carefully placing parity bits to cover data bits. Application range from computer memory to telecommunications emphasizes their importance and data integrity. Challenges in implementation. Implementing Hamming codes requires careful consideration of error rates and performances. Real-world applications may involve trade-offs between complexity and reliability. Continuous advancements in error correction detection techniques are necessary to meet evolving demands. Thank you.